Hello everyone. Let's learn how do batteries work with examples. A battery is a device that converts electrical energy into chemical energy for storage. It does this by using electrochemical reactions to move electrons from one electrode to another through an external wire. This movement of electrons is what we call electric current. The chemical energy stored in the battery can then be released by reversing the electrochemical reaction, allowing the electrons to flow back to their original electrode. This is how rechargeable batteries work. They allow for the reversible movement of electrons and ions, which makes it possible to store and retrieve electrical energy. In this video, we will go over how do batteries work and the different types of batteries that exist. We will also give you some examples so you can see how they are used in real life. So make sure to watch until the end. Batteries are everywhere these days, from the phones and laptops we use every day to the cars we drive. But have you ever wondered how do batteries actually work? Well, let me explain. To understand how do batteries work, we first need to understand what electricity is. Electricity is simply the flow of electrons. Electrons are negatively charged particles that orbit the nucleus of an atom. When a battery is connected to a circuit, it creates a flow of electrons from one terminal to the other. This flow of electrons is what we refer to as electric current. The amount of current flowing through a circuit is measured in amperes or amps. The other important concept to understand is voltage. Voltage is basically the electrical pressure that pushes electrons through a circuit. It is measured in volts. The higher the voltage, the more pressure there is to push the electrons through the circuit. Finally, we need to understand resistance. Resistance is the opposition to the flow of current. It is measured in ohms. The higher the resistance, the less current will flow through a circuit. Now that we have a basic understanding of electricity, let's take a look at how a battery works. A battery is essentially a container that stores chemical potential energy. This energy is stored in the electrodes of the battery, which are made of special materials that can accept or donate electrons. The electrodes are then placed in an electrolyte, which is a liquid or paste that conducts electricity. When you connect a battery to a circuit, a chemical reaction occurs that causes electrons to flow from the negative electrode to the positive electrode through the external circuit. As electrons flow through the circuit, they do work, such as powering a light bulb or driving a motor. Once the electrons reach the positive terminal of the battery, they are then used to generate electricity. One of the simplest types of batteries is called a primary cell. Primary cells cannot be recharged and are typically used for devices that require low power, such as watches or remote controls. An example of a primary cell is the alkaline battery. Alkaline batteries are widely used in devices that require low power because they have a low internal resistance, which means that they can deliver a steady flow of current without losing much voltage. Another type of battery is the secondary cell, which can be recharged. Secondary cells are commonly used in devices that require high power, such as laptops or electric vehicles. An example of a secondary cell is a lithium-ion battery. Lithium-ion batteries are popular in devices that require high power because they have a high energy density, meaning they can store a large amount of energy for their size and weight. They also have a long cycle life, which means they can be recharged many times without losing their ability to hold a charge. Now let's get into the different parts of a battery and how they work together. First off, you've got the anode, which is the negative electrode. Think of it like the starting point for the electrons. Electrons are negatively charged, so the anode is where they begin their journey. Then we've got the cathode, which is the positive electrode. It's like the destination for the electrons. As the electrons travel through the external circuit, they eventually reach the cathode. Between the anode and cathode, we have the electrolyte. This is like the highway that the electrons travel on. The electrolyte is a substance that allows the electrons to flow from the anode to the cathode. It could be a liquid or a solid, depending on the type of battery, and then comes the separator. It's like a security guard that keeps the anode and cathode apart. The separator is a porous membrane that allows ions to pass through, but prevents the anode and cathode from touching each other. This is important because if the two electrodes touch, the battery won't work properly. Okay, now let's see how it all works together. When you connect a battery to a circuit, chemical reaction occurs that causes electrons to flow from the anode to the cathode through the external circuit. At the same time, ions move through the electrolyte from the anode to the cathode. This flow of electrons and ions creates a current that can be used to power devices. As the electrons flow through the circuit, they do work, such as lighting up a bulb or powering a motor. Once the electrons reach the cathode, they are used to generate electricity. The chemical reaction that powers the battery continues until all of the reactants are used up or the battery is fully discharged. Now let's look at the process of charging a battery. When you charge a battery, you essentially reverse the chemical reaction that occurs during discharge. This causes electrons to flow from the cathode to the anode through the external circuit and ions move through the electrolyte from the cathode to the anode. By doing this, you restore the battery to its original state and make it ready to use again. So let's do a quick recap. The anode is the negative electrode where electrons start their journey. The cathode is the positive electrode where electrons end their journey. The electrolyte is the substance that allows electrons to flow between the anode and cathode. The separator keeps the anode and cathode from touching each other. And finally, the chemical reaction that occurs in the battery causes electrons to flow from the anode to the cathode, creating a current that can be used to power devices. Now that you know how batteries work, let's take a look at some examples of how they are used in real life. Batteries are used in everything from small electronics like watches and phones to larger devices like cars and trucks. For example, most phones use lithium-ion batteries because they have a high energy density and can be recharged. Electric cars typically use lead-acid batteries because they have a high power output. And in addition to powering devices, batteries are also used for energy storage. For example, solar panels often include batteries that store excess solar energy that can be used later. Hopefully this video has helped you understand how batteries work. If you enjoyed this video, please leave a thumbs up and subscribe for more videos about technology. Thank you for watching.